Let me explain this program. The first two lines here is to declare two variables, a and b. The variable a and b has been declared, so it has to locate somewhere in the memory, somewhere in the computer, in the memories. And we put the value of the a and b like this. We put 20 into a, we put 30 into b, and then we use the printf function to display the value of this long text. The %d, it means to the program, the C language will replace the %d with the value from the variable a. At the same, similarly, it will replace the %d here with the value of b here, because we put a here and we put b here. But sometimes we want to know that where exactly a and b locate in the address in the computer. If we want to know, or we want to show, to display where is the address, where in the memory that the value a is stored, because it has to be stored in a memory somewhere. Okay, we just run this program. It will be printed out or display 4 lines. The first line here, the second line, the third line, and the fourth line. At the end of the line we have a backslash and n. It represents the new line. So we have this backslash n. It means that the next line will be displayed on the next line, not the end of the first line. Just like this, the value of a is 20 because we put a here. The value of b is 30 because we put b here. The next command, we show the address of a is here. Note that now we don't use %d what we use, but we use %p. P represents pointer, or it means address in a memory. But here, as you can see here, a is a variable. If I put the symbol and symbol in front of the variable a, it means that we need the address of a, not the value of a. In contrast with this command, we put only a here because we need the value of a to be displayed. But in this case, we don't need the value of the variable a, but we need the address or the place where in the memory which variable a located. So see at the result, this is the address of a and this is the address of b. It is represented in hexadecimal because the address is so long. So we normally don't use binary to display that. We normally don't use a decimal 10 base to display that. Normally we used hexadecimal because we can display address in very shorter manner like this. As you can see, the address of A ends with 60. The address of B ends with 64. So the two address is next to each other. First we have A there in the memory, and next we have B here in the memory, because each of the integer each of the number need 4 address or 4 bytes to represent one number.